Okay, so for 5.6 inverse trig derivatives, we actually already did this. Remember the week that we did L'Hopital's rule back in December? And I also taught you then how to derive e to the x and how to derive natural log of the x. We didn't really remember a lot of it. We kind of remember that we did it. Okay, I just wanted to expose you to it. We also did derivative of arc sine of u and derivative of arctan of u that same time. Okay? At that time, I kind of told you, hey, if you have y equals arc sine of x, that's the same thing as saying sine of y equals x, because these two things are inverses of each other. And the way we actually derived these formulas, I think maybe just one of them, by doing implicit differentiation. Okay? You could always do the problems that way. In fact, there are some teachers that they don't even teach these formulas, they just do implicit differentiation. It's a heck of a lot of more work than what we're going to do. So it is worth it, in my opinion, well worth it to know these two formulas. Okay, you will never be, I'll never put these formulas on a quiz or a test. You have to know them, which means you really have to know them in order to do the derivatives. Now remember your green flashcards. You still have them, right? Yes. Okay, two of them are these two derivative rules right here. Tomorrow you're going to get a new flashcard with integral rules. And I'll put them on a different color just to kind of distinguish, but you actually already have two flashcards with these two, so you may want to be studying those. If you notice, derivative of arc sine of something, it's a fraction, and on the top of the fraction is u prime. What does that sound like? What's something else we did where the derivative was a fraction and the top was the derivative of the thing in parentheses? Natural log. The derivative of natural log was derivative over itself, u prime over u. This one's a little bit more complicated than that, but we still have a u prime on top. And notice for both for arc sine and arctan, they both have u prime. Okay? We'll do an example here in a minute. The difference is arc sine is square root of 1 minus u squared, and arctan doesn't have a square root, it has a plus. So they're similar, so you don't have to memorize two totally different things, but you do have to keep them straight. A couple of things before we actually differentiate. I want to talk about the graphs here, and this is going to help us with some problems later on, and the domain and range. Okay, so remember arc sine is the inverse of sine. Okay, so its graph, you know how sine looks, it's like the inverse, and it looks kind of like that. And we started and stopped. It had what we call a restricted range. Do you remember that phrase, restricted range? Anybody? Okay, maybe not from pre-cal. Not from this class, we haven't talked about this. So its restricted range was negative pi over 2 to pi over 2. Okay, that's what the restricted range was. And I'm going to write it here because it's the same for both of these. What this means is, if you take arc sine of something and the same thing happens with arctan, the result is always going to be between negative pi over 2 and pi over 2. So if I said, find arc sine of blah blah, okay, it's what your answer has to be between these two numbers. Okay? The domain, though, the domain is differently. You can't just take arc sine of anything. Kind of like how, remember we could only take natural log of positive numbers? You can only take arc sine of numbers between, okay, so let's think about this. The domain of arc sine is the same thing as the range of regular sine. Do you remember the range of sine x, bottom to top? Negative 1 to 1. So if we were maybe doing intervals of increasing and decreasing, we would only be looking at the interval negative 1 to 1 and breaking that up. We can't even consider numbers less than negative 1 or greater than 1. Okay, don't get too, this is not the majority of what we're learning today, but I just kind of want to put this out here now, and then later on we can discuss how it affects calculus. Okay, arctan, the graph, you may or may not remember. Again, it looks like one cycle of tangent, but it's kind of thrown on its side, meaning it's like reflected like that. In fact, that's what inverse is. It's a reflection over the line y equals x. So we still have a, oops, I didn't mean to do that. We still have a restricted range of negative pi over 2 to pi over 2, meaning if you take arctan of whatever, it has to be between negative pi over 2 and pi over 2. All right, however, is there a restricted domain? Look at that domain there. It's what? All real numbers. And if you remember, regular tangent had a range of all real numbers. It went forever up and forever down. So that's how that works. Okay? So, with all that being said, we're not even going to deal with that for a minute. We'll get to it towards the end of the lesson, though. Okay, what we really need to focus on, though, right now are the formulas. Okay, figuring out which formula to use and how to use it. Okay, today you're not going to have them memorized, but you do need to have them memorized soon. All right, so differentiate part A, or example A. Remember, it's a fraction, and on the top of the fraction goes the derivative of, in this case, 2x. So what goes on top? 2. That's true whether you're doing arc sine or arctan or natural log. What goes in the denominator, you have to really think about the formula. It's arc sine, so we're going to do square root of 1 minus, and in this case, u is 2x, so I'm going to go ahead and put 2x in parentheses and square it. You do not have to simplify, although on a multiple choice test, it might be written as 4x squared with no parentheses. I'm confident y'all would be able to pick out the right answer. Okay, so for example B, very similar problem. Instead of 2x, it's 3x. But now we have arctan, so we have to use this other formula. Still though, fraction bar. What goes in the numerator? 3. The denominator is going to be 1 plus u squared. So 1 plus, in this case, 3x squared. And probably on a multiple choice test, this would be 9x squared. You don't have to do that. We'll worry about simplifying later when we get closer to the AP test. Right now, we just need to focus on correct answers. Okay, so then we look over here at C. And so this was kind of a question that was brought up earlier. Look at what's different about C. We see a product. I see x in 2 different places. Do you see what's being multiplied to what? X is being multiplied to arc sine of x. So those are your 2 things. So my y prime is going to be derivative of x, 1. And remember, don't do derivative back to back. I know I say that a lot, but I see that as the most common mistake. Okay, plus. Now we just write x, and we do derivative of arc sine of x, of square root of x. So this is going to be a fraction. What's going to go in the numerator? Yeah. The derivative of square root of x, which is the same as x to the 1/2, is 1/2 x to the negative 1/2. That's the u prime or du or however you want to say it. In the denominator, because it's sine or arc sine, we put a square root and it's 1 minus. If this had been arctan, we would have not put the square root and put 1 plus. That's the difference between the 2 formulas. And remember, you got to take that square root of x and you got to square it. And that's your answer. Could this be simplified? Definitely, it could be.
Could that, the 1 minus square root of x squared, can you just say x?
Yeah, that definitely simplifies to x, and then this up here may look like a square root of x in the denominator, and the 1/2 may look like a 2 in the denominator. So there's a lot of things that can be done, but yeah, you could say square root of x squared is x. All right, D. Do I need to use product rule on this one? It's 6 times arc sine of e to the 2x. Could you use product rule? You could. Half of it would be 0 because the derivative of 6 would be 0. But since 6 is just a number, you just get to go 6 times whatever's next. You get to do that with a number. We could not have done that if it was 6x. That wouldn't have worked. And so arc sine of something I know is always a fraction. The top of that fraction is going to be the derivative of this thing in parentheses, which we just had a quiz over. We'd rewrite it as e to the 2x times derivative of 2, or 2x, which is 2. Okay, sine, again, or arc sine, is square root 1 minus, and then e to the 2x squared. And that's your answer. Could it be simplified? Sure. You don't have to do that. Okay, so that's how you take derivative. Now, if I gave you these formulas, this would hopefully be super easy for you. The hard part about this is knowing the rules, knowing the formulas. It's just like anything else, though. You got to practice it. You got to study it. Okay. Number 3. First of all, I am going to take out, we're not going to even talk about concavity. All right, if we're going to, though, do any of this, what's our very first step? Find the derivative. That's how we do all of these. So we find the derivative. This is a chain rule, so I'm going to go 2 times, keep the inside the same. Put down the power by 1. Times, now we got to go times the derivative of arctan x. Okay, go ahead and write down on your paper what you think derivative of arctan x would be. Feel free to look at the formula if you need to. Okay, I got 1 over 1 plus x squared. All right, probably a slightly easier way to think about this, because I'm going to have to do something with it, is actually just to go ahead and write this as arctan x over 1 plus x squared. This is going to be easier because the next thing I need to do is figure out when is this derivative equal to 0 and when is it undefined. With a fraction, it's not too bad. You can just set the top equal to 0, set the bottom equal to 0. So let's do this. 2 arctan x equals 0. How are we going to solve this by hand without a calculator? What are we going to do? So how are we going to do that? Let's divide by 2 first, and I'm going to just scratch it out because 0 divided by 2 is 0. What is just x? If arctan of x equals 0, then x equals tan of 0. That's what arctan means. It's the inverse of tangent. Okay, this right here equals tangent of the number on the other side. So what's tangent of 0? Trig. Okay, do you know what sine of 0 is? More people know sine of 0. 0. What's cosine of 0? Okay, isn't tangent just sine over cosine?
Yes.
So what's 0 over 1?
0.
0. That's one way to do it. There are many ways. There are many ways to do this. But if you're like, oh, we haven't done tan in a while, just think of it as sine over cosine. So this is a critical number. Let's see if we have another one. Let's set the denominator now equal to 0. What we're doing now is saying, hey, is this thing also undefined anywhere? Undefined would be when we divide by 0. And I get x squared equals -1. And oops, I'm square rooting a negative. We get to quit. In this class, we do not deal with imaginary numbers. Okay. The other thing you kind of need to see is, can I take arctan of any number? Do you remember what the domain of arctan was? All real numbers. We can take arctan of anything. If this was arc sine, this problem would actually be much more difficult. Okay, so here's y prime, here's y. Okay, remember here's what we're plugging this into, right there. So we got to take a negative number, okay? 2 times arctan of a negative number. Is that a negative number or is it a positive number? Look up at the graph if you need to. This is why we kind of did this first. If I if my x is a negative, is my y also a negative
Yes.
or positive? Negative. Here's the great thing, both for tan and sine, arctan and arc sine. If you take arctan or arc sine of a positive, you get a positive. If you take it of a negative, you get a negative. This is another reason why we should be really glad we're not doing cosine, because it doesn't work exactly the same with cosine. So that's a negative there, because the denominator is always positive. So my function's decreasing. That was part of what it's asking me. Decreasing negative infinity to 0 because the first derivative is negative. What happens when you plug in a positive number? Arctan of a positive number is a positive number. The denominator is always positive. This is not something you are going to compute. This is something where you really just have to say, is the result positive or negative? And so increasing would be from 0 to infinity. Again, first derivative is positive. And so that's all we're going to do on this one. Just in general, though, how would we do the concavity part? Find the second derivative and do something very similar. We're not going to do that. Okay, the very last thing that I want to talk about is something that I didn't put on your notes, but in hindsight, I wish I had. And that is we need to practice a little bit of inverse trig evaluating. And I'm going to explain to you why in just a moment. So just wherever you have space, we're not going to do a whole lot of this, but just somewhere on that page. Okay, arc sine of square root of 3 over 2. I want to know what that is. Okay, you probably are not going to be able to just pick this out of your brain. Okay, that's okay. Eventually you will, hopefully. So we're going to say this is the same thing as saying sine of what equals square root of 3 over 2. If you can just make this connection, you can do any of these. So we're looking for an angle. Is it 30? Is it 60? Is it 45? Is it 0? Is it 90? You put this, you guess, and check. You only have a few options it can be. So what do you think? 60. So 60 degrees, which is the same thing as pi over 3 in radians. We need to be in radians. All right, how would this change, though, do you think, if this was arc sine of negative root 3 over 2? In other words, how would that change my answer? Don't think too hard on this. First instinct is probably right. It would just be negative
11 over 6.
We could, you could write it as 5 pi over 3. It's better to just write it as negative pi over 3 because of the whole restricted range thing. All right. Now with arc sine and arc cosine, it's as easy as this. You take arc sine, arc cosine of a negative, you get a negative. With arc, I don't know what I just said, sorry. With arc cosine, it's more complicated. We would have had to do pi minus. Any of this ring a bell from last year? Not that you remember it, but that you remember that there was such a thing. Okay, again, this is really good that we're only really focusing on these two. Okay, let's just do one more. Let's say, what is arctan of 1? And remember, your answer, here's another thing, your answer has to be between negative pi over 2 and pi over 2. It can't be outside of that interval. That was what restricted range meant. So we would say sine of, how did I say sine? Tangent. Tangent of what equals 1? So again, it's like 30, 60, 45. It could be 0 or 90. It could be one of those two. But it can't just be anything. So what do you guys think? How'd you get that?
Because tangent is opposite over adjacent, and so they would have to be the same.
So it had to be where, it had to be a 45, 45, 90, where the two sides are the same. Okay, so some of you, this is going to be a little bit more difficult than others. Turn the page. This is your homework. You have a little bit of time. It's just 4 derivatives. Yeah, you got to do a little bit of extra stuff on those, and then you have 2 tangent lines. I didn't work a tangent line in class. We've been doing tons of tangent lines, but this is, I am going to give you a little hint here. To find the y value, because right, don't you need an x and a y, and you need a slope, right? You're given the x, you're not given the y. You are going to have to find the y value. And you do that not by finding derivative, that's for slope, but you do that by evaluating this thing right here. So in order to find your y value, you are going to have to do a little bit of trig. It's not the world's hardest problems. You can do it. Okay, you don't even have to simplify it, but you do have to evaluate what arc sine of 1/2 is. And the slope, obviously, you would do derivative.